Situation normal, everything must change. My name is Simon Wardley. I'm from Kent in England. England is obviously famous for coming second in the World Group C table to a country which can't even spell the game correctly. A bit of background on me. I've been a businessman, I've been a consultant, and I'm a scientist by training. And these days, I research for the LEF, the Leading Edge Forum, a research and global advisory group. Now, before I start, a word of warning. Being a scientist, I like graphs, so I plotted a quick graph, the level of audience pain against the number of slides given in a 30-minute presentation. And I reckon there's a safe limit of around about 20 slides, so I'm going to be experimenting today and using no less than 279. I know what you're thinking, but don't worry, there will be plenty of signposts along the way. Now, I've been given some extra time, so I thought I'd recap my last talk that I gave at OSCON, which was about cloud computing. So what is cloud? Well, here is NIST's definition of cloud computing. If you can't read it, that's good. The only useful thing it says is that cloud computing is still an evolving paradigm. That's consultant speak for we don't know what cloud is yet. But don't worry, as Steve Ballmer, Microsoft's CEO, said, the real thing to do today is to capture what are the dimensions of the thing that literally I will tell you we're betting our company on, and pretty much everybody in the industry is betting their companies on. Translation, we don't know what cloud is yet. Bet your company on it. Everybody else is. The good news is that cloud does open up exciting new prospects for the employment of computers in ways and on a scale that would have seemed pure fantasy only 5 years ago. The bad news is this was written in 1966 by Douglas Parkhill in the Challenge of the Computer Utility, where he said that in the future, computer resources would be provided just like electricity through large utilities. These installations would have certain characteristics. They would be online, they would be elastic, they would be utility-based. They would have multiple deployment models, private, public, community, and government utilities, and they would offer services from hardware to applications. By pure coincidence, 44 years later, this is what NIST says the cloud is. Of course, NIST is an American organization, and you have form when it comes to changing names. So today, I'm going to review my previous talk pretty quickly, and I'm going to introduce the ideas of change and use that to explain cloud computing. And then we're going to get a lot more complex. I'm going to look into the concept of organizational shape and how companies deal with change, look at some consequences of this, and then propose some new patterns that are emerging for organization. So I'm going to start by plotting a graph of how business activities change. I'm going to use one axis for ubiquity, another axis for certainty. So basically how common an activity is against how well-defined and standardized it is. This is some real data, and this data suggests there's a relationship between the ubiquity and the certainty of an activity. It suggests a pathway for how new activities evolve, from a rare and poorly understood innovation to a common and well-defined commodity, through distinct stages such as innovation, custom-built product, commodity, and utility services. Now, you can see this change by looking at something like CRM, customer relationship management systems. We started off with the innovation of early lists in the 1980s, custom-built database marketing systems in the mid-80s, the introduction of products around about the early 90s, and then the introduction of utility services like Salesforce. This change has also happened to infrastructure. So we've gone from the early innovation of the Z3 in 1941 to the introduction of custom-built systems like Leo, the introduction of the first products like the IBM 650, all the way up to commodity hardware, and then the introduction of utilities like services such as Amazon. This change doesn't just happen to IT, it happens to any business activity. So you can look at the transition of, say, the electricity industry, and we started off with the innovation of Wollaston, 1821, the introduction of the first products like the Hippolyte Pixie, and then on to the introduction of utility grids and eventually the national grids. So all business activities are somewhere on that curve, and all of them are moving. They are evolving along their life cycle. They are literally commoditizing. So why does commoditization occur? Well, ask any businessman, and they will tell you, and if you've seen this before, you will know that business is little more than warfare. It's a catfight. And as soon as one company gains some form of technological advantage, some new big gun, like an e-commerce site, then everyone else will follow suit. This creates a constant demand for anything which is useful, but of course there's a competition for the supply of this new stuff as well, and so any time anyone introduces some new thing, like kit and body armor, someone else will make a better version. There is a constant drive for improvement. It's these combined forces which actually drive the process of commoditization and the constant evolution of activities across their life cycle. So, what is cloud then? Well, quite simply, a whole bunch of activities which were once innovations but more recently have been provided as products with feature differentiation have now become so widespread and so feature complete, they've moved up that curve and become suitable for utility service provision. Cloud simply represents an evolution of a bunch of activities across the computing stack from a product to a service world. So why now? Why is it occurring now and not, say, in 1966? Well, cloud computing requires a number of different factors before it could occur. First of all, you need the concept, but that was 40 years ago. Secondly, you needed activities to be suitable for this change, i.e. so widespread and so well-defined that they would support the volume operation of these providers. That's happened in the last 10 years. You also needed the technology, things like virtualization, but we've had that for some time. But the key critical factor is that you needed a change in business attitude. You needed companies willing to use these services. Well, the attitude of business to IT has been changing since the 1990s, ever since Paul Strassman showed that there was little value in much of IT spending. This was then refined by a chap called Nick Carr, who showed that as activities became more ubiquitous, they had diminishing strategic value. So at a recent forum, 60 CIOs, they all identified these activities as having little or no strategic value to their organizations. They're all nothing more than a cost of doing business, which of course begs the question, why are they spending $600 million per annum on customizing stuff which has no strategic value? Obviously, what they're looking for is standardized services, ideally provided through a marketplace of providers. So the attitude of business to IT is changing, and so we have concept suitability, technology, change in business attitude, and this is what is driving the shift from a product to a service world. And this is what cloud is all about. And well, are there risks with cloud computing? Of course there is. I mean, one of the risks is that it's highly disruptive to the product world. A second risk are known as transitional risks. These are, for example, trust in these new providers, issues of governance, security of supply, and general security. Finally, there are outsourcing risks, such as is there locking to particular vendors, is there pricing competition, is there loss of strategic control, etc. Are there benefits to cloud computing? Of course they are. But these benefits are little more than standard benefits of commoditization. So, for example, they're things like increased efficiency, increased agility, and the ability to focus on things that are core. Now, you don't have to use cloud services in the same way that you don't have to use standard electricity supply. You could, for example, build your own generators, your own standards, etc. But the only thing you're likely to create is a competitive disadvantage for yourself as everyone else takes advantage of the benefits. As any activity moves along its life cycle, there is always a competitive pressure for you to keep up. Now, this is known as the Red Queen hypothesis. Formally, it states the need to constantly evolve in order to stand still relative to our surrounding ecosystem. Quite simply, IT is an arms race, and there is no point turning up to the catfight with a snazzy rifle if everyone else has got tanks. But at least cloud will reduce your spending. Well, I'm afraid not. As noted in Jevons paradox of 1865, technology progress that increases the efficiency with which a resource is used tends to increase the consumption of that resource. Cloud is not going to reduce your IT spending. What you're actually going to end up doing is more stuff. Why? Well, most companies have a long tail of unmet demand, and as we increase efficiency and agility, this demand could be met. But more importantly, the shift from a product to a service world should accelerate innovation in IT. And there are two reasons for this: componentization and creative destruction. And I'll quickly go through this. So creative destruction. Joseph Schumpeter once explained that the impulse that keeps the capitalist engine in motion is the constant creation of new stuff, but this new stuff requires destruction of value in the old, and hence he coined the term creative destruction. Since commoditization of any activity erodes value, it therefore enables innovation. For example, you need easily available power, data processing, communication before you can have the new stuff like search engines and Googles. However, commoditization does far more than this. It just doesn't enable, it accelerates the process of innovation through a concept known as componentization from Herbert Simon's theory of hierarchy. And formally, it states the rate of evolution of a system is dependent upon the organization of its subsystems. For example, let's take the Industrial Revolution. In the early days of the Industrial Revolution, every machine was made with individually made nuts and bolts. One nut would fit one bolt and no other. And then Maudsley introduced the screw-cutting lathe, and suddenly you had interchangeable components. And as a result, there was an explosion of innovation. So as we see computing resources shift from being provided as products to standard components as services, we should see a corresponding acceleration of innovation in this industry. So I'm going to quickly recap all of that. Cloud is a simple but real change. It's driven by a number of different factors, such as concept suitability, technology, change in business attitude. There are many different types of risks involved in cloud, along with many benefits, such as increased efficiency, agility, and the ability to focus. Overall, companies are going to be under increasing pressure to adopt cloud services, especially as their competitors do. Cloud will cause further innovation within the IT industry, and don't expect it to save you any money. So now I'd like to explore the concept of shape. A word of warning, this stuff really gets complex. So any business consists of a mass of different activities, all at different stages of their life cycle. So I'm going to plot another graph. This is life cycle against the frequency of activities at that stage of life cycle. If you plot a company, the result is an overall shape for that company. At one end, you have those new innovative technologies, Enterprise 2.0, information markets, and so forth. At the other end, you have those more commodity-like activities, electricity, infrastructure, payroll, and so forth. Of course, all activities are moving along this curve. They are, across this graph, they're being commoditized through multiple forces, demand and supply competition. And as a result of this, this enables new innovation through things like creative destruction and componentization. So why care? Well, the innovative activities have certain properties. They are dynamic. They must deviate from what has previously existed. They are uncertain. You never know if it's going to be successful. They have emergent characteristics, i.e. we learn about them as we use them. Luck often plays a big part in their development, but they are a source of competitive advantage and worth. These activities are chaotic by nature. Now, on the other extreme, you have a bunch of activities which are different. For example, they are repeatable, are often used throughout an entire industry. They tend to be much more standardized. They are known. You often have best practices. They are measurable, predictable. They're often very suited to well-defined procedures, but they are little more than a cost of doing business. They provide no differential advantage. These activities are generally described as being linear of nature. And then, of course, you've got the activities which are in between, in transition between these two stages. Now, any activity like CRM passes through each of those stages. And so why does that matter? Well, let's take something very simple, like project management. Let's say you've got some consultants in, and they say you should use Six Sigma. Well, Six Sigma is a fantastic methodology for dealing with these linear activities. Why? Because their characteristics are predisposed to it. Six Sigma reduces deviation. This is exactly what you want. But at the same time, Six Sigma absolutely sucks when it comes to managing innovation, because it tries to reduce deviation where deviation is in fact something you want. So use Agile instead. Well, Agile is fantastic at managing these innovations because it encourages deviation and change, and it's suitable for the properties of those activities. But it sucks when it comes to managing managing more linear activities. You don't want, for example, change and deviation in your electricity supply. The general rule is there is no magic bullet to things like project management. You have to change methodologies according to lifecycle, and getting this stuff matters because the stuff on the left-hand side is your future source of value, your future source of survival tomorrow, whereas the stuff on the right-hand side is all about competitive efficiency and therefore survival today. And this is known as the innovation paradox. Survival today requires coherence, coordination, and stability, whereas survival tomorrow requires the replacement of these erstwhile virtues. A couple of observations. One, the term innovation. I use Fagerberg's definition. Innovation is the first attempt to carry out an idea in practice. So, for example, you have the innovation of the Z3, and then you have the introduction of products, which are all about feature differentiation, and then eventually the introduction of services, which are all about operational efficiency. The problem is we like to use the wrong name for things. So we end up with people calling everything an innovation. Product innovation. Yeah. Just because you take an umbrella, say, and combine it with a phone, doesn't mean you've created some new innovation. You've actually created a feature differentiation. So there are a number of accelerators to these processes. For example, network effects, open source participation systems will drive commoditization, and there's a number of counterforces people use, things like pricing, confusion, and branding. So quick recap. Any organization consists of massive different activities, all at different stages of their life cycle. If we plot the frequency of activities against their life cycle, we come up with a shape for an organization. This shape is transitory because things are being commoditized at the same time as new innovation is appearing. Any activity obviously moves through these different stages, and this is why there is no magic bullet to things like project management. And getting this stuff right matters because on one side it's about survival tomorrow, the other side it's about survival today. So what's the typical consequences of not understanding this? Well, the first one is the misapplied process, and that's common. That's the one-size-fits-all approach to dealing with things. Second are the common misunderstandings around cloud. So people talk about cloud as though it's all about cost reduction, where in fact cloud is more about increasing agility and innovation. My third favorite is the efficiency versus innovation argument. To explain this one, I'm going to pretend we're all in a startup. So we're all in, who's been in a startup, roughly? Great. Who's been in a startup which has got big? Okay, so this will probably, you'll probably recognize this. So let's say we're going to start something new. We're going to create the first ever kitten internet, okay? So we're a startup company, and as a startup company, we have our kitten internet here, but we have all those other activities that we have to manage and deal with as well. Things like accounting systems. Now, because we're a startup, we tend to treat everything as new, including the accounting systems, so our profile is a little bit skewed. And because we're a startup, we generally tend to use Agile everywhere. But that's great because, it encourages innovation, and at the end of the day, that's what we're about. We're about the future. So who cares? Well, the boss cares. The boss cares because he realizes that other competitors are more efficient at dealing with some other activities. So eventually, you will hear him say, we need to be more efficient. So you get the consultants in, and they will tell you need more process. And what you do is you introduce some, well-defined procedures, and suddenly the payroll system, stops changing every week. The holiday request form suddenly becomes something more stable, and we feel like a proper grown-up company. So, our profile has now got back to something a bit more sensible. And then what happens, of course, is those processes start to spread, until eventually everything we're actually doing is now controlled by a well-defined process, which is, of course, sucks for innovation. But who cares? We're a grown-up company now. We're efficient. Well, the boss cares. And the boss cares because he's now noticed that other competitors are being more innovative than we are. And we were the company who created the future. We were the company who gave the world kit and internet. So eventually the boss will say, we need more innovation. Actually, what you need is less process, a more balanced view of the world. But the consultants will never contradict themselves. So you always end up with the worst thing in the world, which is an ideas process. Now you know you're in trouble. Okay, the next consequence is bits to services. Any innovation which is useful, like computing infrastructure, will tend to spread and eventually becomes a commodity as long as there's no constraints. Now, ideally for a consumer, what you want is a marketplace of providers, but this marketplace of providers requires several things. First of all, you need multiple providers. Secondly, you actually need access to your code and data, i.e. open APIs and data formats. And thirdly, you need interoperability. There's no point in getting your code and data out of one provider if another provider doesn't understand it in the same way. So what you actually need are common reference models, or running code, which is used between both providers. Now, if that reference model is owned by somebody, it's what is called a captured market. Yes, you can create a marketplace of multiple providers where you can switch between them based upon a proprietary technology, as long as everybody is willing to hand over future technological direction and strategic control to one party, which generally requires a marketing department who can persuade people that freedom and free choice depends upon you being in control. Now, the sane alternative is actually what is known as a free market, i.e. free of constraint, which means the reference models have to be open source. Fortunately, there are some enlightened companies who are actually doing this, so Rackspace with OpenStack. And of course, once OpenStack gets going, they'll create a marketplace of providers, and people say, where is the money? Well, there's always lots of money in things like being a provider, a broker, assurance, exchange service, market insurance, and support, all of which are services which don't require locking. Last issue, I want to talk about alignment. We generally group activities by type, so IT, admin, business, or whatever, and then we organize ourselves by such departments. The problem with this is that you just need one department to incorrectly treat their activities, and you have alignment issues. If I go back to the example of the CIOs, the reason why they were spending 600 million customizing stuff that had no strategic value wasn't because of some inefficiency in IT, it's because the business believed that customizing a common process actually gave them an advantage. So it was a misalignment in the business which caused misalignment with everyone else. Of course, none of this stuff matters as long as your competitors suck as much as you do, say, at doing project management, alignment, and all the rest of it. Of course, it only really matters when new patterns emerge and there are new ways which suck less. So rather than organizing by type, there's other ways of organizing yourself, by life cycle. Now, you can actually, there's an extreme form of this, and I won't go through this, which is actually organizational structure by life cycle. What I'm instead going to do is talk about a general pattern known as innovate, leverage, and commoditize. So I'll take an example. Google, for example, use a number of techniques, 20% work rule, summer of code, which helps encourage innovation. They also leverage their ecosystem of users and employees through things like Google Labs, and then they often acquire companies. And they often then take an approach of commoditizing by providing this stuff as core services or core APIs. So I'll give an example. Geographical information systems, innovation back in the 60s, infograph in the 80s, where to appeared, Google acquired them, created Maps and Map API. Then on top of Maps, things like Google Ride were created. Unfortunately, Google Ride was put into Google Labs, wasn't successful, discontinued. But other services, such as Google Transit, which came from the 20% projects, were put into Google Labs, were successful, and then eventually became part of the core services. So what's happening here is you've got this core center. What you're trying to do is encourage an ecosystem around you. You're trying to encourage innovation in the ecosystem, and then you're leveraging the ecosystem to identify things which are likely to be successful, driving them into core services, and then providing those to enable the next wave of innovation. So innovate, leverage, commoditize. And this is roughly a pattern which is followed by many different companies. Google is an example. And it doesn't matter whether they consciously follow or not. The pattern keeps on recurring. And Salesforce is another example. So why does this matter? Well, it matters to me because this is my area of research for the LEF. But it also matters to me in another way, because last year at OSCON, somebody said to me they wanted to create an open source company, but they couldn't work out a new idea, a new thing that they could create. And the reality is, neither could I. Innovation is very, very tough. So I thought about it, and I realized you don't need to. All you need to do is find an activity which is fairly ubiquitous and well-defined and understood, for which companies are paying huge amounts of money because they're customizing a product, when ideally what they actually want is a standard service through a marketplace of providers. Now, there are many examples of this, and those activities are ideal for disruption. They're prime for it. Ideally, you want your competitors to show all the hallmarks of a company that is not going to be able to respond to you. One-size-fits-all ideas, process, etc. Don't fear size or resources that these companies have. Their incumbent models will actually protect you. Then what you want to do is provide the service as open source, encourage the formation of a marketplace, and then use both the open source element and the marketplace and APIs to create an ecosystem, which then you use that ecosystem to innovate, leverage, commoditize. And then you just rinse and repeat. Now, if you do this, you should find yourself on the wind of change with the competitors barely hanging on. And if you want to make money, focus on services. Being a provider, being a broker, being an exchange, and so forth. So I went looking, and everywhere I went looking, I found examples or sections of the marketplace which are ripe for such a disruptive approach. I never realized the profoundness of something that Jesse Robbins said, you become what you disrupt. There are huge markets here to be taken. So my take-home message is go take them. Go disrupt them, and go build the golden age of open source. Thank you.